Howdy folks, and welcome to part 6 in my comprehensive guide to pfSense 2.3. In this video, I want to talk about the DHCP server. Most networks will employ a DHCP server, so it's one of those incredibly important and often forgotten services in a network. That and DNS, which is coming up in part 7. So I want to go over, I'm not going to go over so much as to what the DHCP server is, because I did describe that at a high level in part 4. I'm just going to go over configuration of the DHCP server, what the options mean, and a few things to look out for. So you can configure the DHCP server by going to Services, DHCP server, and you will be presented with a page which allows you to configure the DHCP server independently for each interface that you have on your router. So in this case, in my virtual setup here, I only have one interface, excluding the WAN, of course, which is the LAN. So I only have one tab here and only one page of options. Now, in the event that I had, let's say, more interfaces, I would have more tabs here. So for example, if I add another interface, and if I enable this interface and I make it static, such that I'll be able to set a DHCP server on it. Let's give it some arbitrary address. Just to show you. Now, if I go to the DHCP server, you will see that I now have two separate pages that I can configure the DHCP server for. And so, depending on the number of interfaces you have, you'll be able to set options independently for each one. So I'm just going to focus primarily on the LAN interface and just go through this once. But remember that they're all independent, so you'd have to make sure the options are correct across all of your networks. So obviously there's some pretty bog standard stuff. Enable, if you want to enable the DHCP server on that interface. You can run a network without a DHCP server. Like I mentioned before, all the DHCP server does is it propagates information from your router to clients. Basically, it provides them with information as to where is the default gateway, what IP addresses they should bind to. It gives them information as to where the DNS servers are on the network, things like that. You can manually enter this information in, and in that case you would have what's called a static network. But generally speaking, nobody wants to go to each device on a network and manually type in all of those parameters and then somehow manually make sure that the parameters are unique and correct across all the devices. So you want this managed automatically, and this is kind of why DHCP is forgotten as sort of a service. It's always there, and you just plug a cable in and your computer connects to the network. Everything just works, and it's DHCP that does that. But someone has to set up DHCP at some point. So you can disable it, but in that case, you would consider your network broken because you'd have to set up everything by hand, but you can disable that if you want. The option to deny unknown clients. This you can kind of think of as sort of like a pseudo security. The idea behind this is you provide the DHCP server with a list of MAC addresses, a list of devices that you authorize can be on that network segment. And if you check this box, what will happen is when a device comes in, its MAC address will be checked against this list of MACs that you've provided the DHCP server with. And if it matches, the DHCP server will give a lease, an address lease to that device. However, if the address does not match, it will basically say, no, I can't give you an address. And the device will not be given a lease, will not be given an address. And by checking the option below it, you can actually have the DHCP server basically act as if it doesn't exist to those devices. So rather than responding, no, I can't give you a lease, it doesn't respond at all. So when a device connects to a network, when you first initiate a physical connection, it will send basically a probe, a DHCP discover. It will try to find any DHCP servers on the network. It'll basically ask sort of the equivalent of, hello, is anybody there? And normally the DHCP server will respond, say, I'm a DHCP server, what do you want? And in which case, it'll request a lease. But in that case, if you've checked both of these, the DHCP server will receive that, hello, is anyone there? But it won't respond, and the device will act as if there's no DHCP server reachable, and it won't be able to get a lease, it won't be able to get an IP address, it won't know the gateway, it won't know DNS, it won't know that kind of stuff. And for the average person, they wouldn't be able to do anything on the network. Their computer would sort of be sitting at the initializing, the trying to connect state. They wouldn't really get any further than that. It is not really security, because anyone who really knows networking will be able to get around this. There's nothing that stops you from manually entering all this information the DHCP would normally provide into your computer. Basically just picking an IP address and hoping that it's not in use. Spoofing MAC addresses. People like hackers can get in if even with these checked. But it's an interesting way to do sort of pseudo security. So if you don't want someone plugging in their their laptop into your network and start doing stuff, they probably will get frustrated and because it can't connect, and then they'll stop doing whatever they're doing. So it is a some level of security, but it's not high security. But that's what those are for. These are non-editable parameters, so the subnet, of course, is dependent on the IP address, the static address that you assigned to your interface. And the subnet mask is the same thing. Whatever you assign to the interface, it just tells you that here. And based on the subnet and subnet mask, it will give you what's called an available range. And this is basically the range of addresses that can be leased on that subnet. So in this case, because the subnet is basically you can't use 0 and you can't use the highest address in the subnet because that's the broadcast address. So in this case, we could use basically anything between 1 and 254. Now 1 is actually used by the network, by the actual interface on the pfSense box. So that would technically not really be usable either. So it's really 2 to 254 in this example. But depending on the geometry you've done here, you could have a whole bunch of addresses or just a couple. And the DHCP server, when a client requests a lease, it will effectively randomly pick an available address from what's known as a pool. And you specify the beginning address and the end address of that pool. So this is the default, just happened to be generated for me from 10 to 245. I'm not sure why it picked these numbers, but it did. And I can edit these. I can make the pool whatever I want. And this is basically any address within this pool is legal and could be assigned to a client. Potentially they all could be assigned to a client if I happen to have 235 devices connected all at once. However, if you want to, you can add extra pools outside of this address. So I could create multiple pools rather than, maybe I didn't want a contiguous block of IP addresses from a low address to a high address. I wanted one block and then a gap of addresses and then another block and then a gap of addresses. If this, if this was an advanced network, you had a reason to do this, you can add a pool. And when you add a pool, what you effectively do is you get the ability to add a new range. It'll tell you what is currently in use so that you can't overlap pools. And basically, in this pool, you can specify a bunch of options independently. So this acts almost like an interface, so that you can actually set different settings for each pool. And generally speaking, unless you're in a big enterprise environment and you have real reasons to do it, I wouldn't recommend adding extra pools to an interface. One pool per interface is perfectly acceptable in like 99% of situations. So this, if you're in a home environment or a small business environment, you probably don't need to worry about this at all. But you have the option to do it if you wish. Win servers. If you know what these are, you can enter them. This has to do with Windows naming service. It's something to do with NetBIOS. Most people don't need to worry about this. If you have a corporate network and you have one of these, you know what it is, enter it here. Otherwise, just leave it blank. DNS servers, generally speaking, I would leave these blank because when they're blank, the router will automatically send the DNS servers that are in use by your pfSense box to clients. So only fill these in if you want to basically override what you're using on your router and send out different addresses to the clients, which is generally not what you'd want to do. But again, if you're in a business environment, you have a large network that's quite complicated, there may be scenarios where that's applicable. So when I do the video in the next part on DNS, I'm going to be relying on the fact that these are blank for that configuration. But you can enter things in here if you want to, but I would recommend that you not, so that way you can take advantage of the DNS forwarder or DNS resolver. You can add you're basically an override to the gateway again. So a lot of these are overrides. So if you don't enter anything in here, it will use the interface IP address as the gateway, which is in most situations correct because you want the pfSense box is your router, but it is also probably your gateway. Your modem is your WAN is probably connected to your pfSense box, and therefore by leaving this blank, it'll automatically populate this with the interface IP. So in this case, it would be the LAN IP address in the opt1 case, or I would rename that to be something better. But in that case, it would be the opt1 IP address that gets automatically populated here. But again, if you're in a big, complicated environment, maybe you're using pfSense for something other than a gateway, and in that situation, you may want to put something custom in there. Again, domain name, same thing. If you leave it blank, it will use the default the domain name that you're using for your pfSense box. So in my in this test example, I think I'm still using the default, which is local domain. But if your pfSense box has a top-level domain like johndoe.com, that would automatically be used. Only really populate this if you need to override it for some reason. Domain search list. This has to do with the way that DNS short names are resolved. I'll cover this in the DNS video, but you can have, of course, you can have your own. You can run your own DNS server, and therefore you can have your own names resolve. So you can have host names resolved by the DNS server. So you can name your computers different things, and they can be resolved. You can set up all sorts of things. But if, for example, I have a computer and it's named Tesla, I'm just using one of my machines for example. Technically, Tesla is not a full domain name. Tesla is what's called a short name. So the actual fully qualified domain name for that machine would be Tesla dot, and then it would be the actual fully qualified domain name. So it would be like tesla.johndoe.com, something that ends in a top-level domain. That's a fully qualified domain name. And that's what you need to send to a DNS server to get it to give you a response. But one nice thing is that if you just enter in Tesla, your computer is usually smart enough to go, oh, I'm on the johndoe.com network, so therefore I should just automatically append johndoe.com to that and then search for it. So what you can do is if you have multiple domain names that could possibly be appended to that short name, again, if you're in let's say a big business or an enterprise environment where you have a bunch of different domain names internally, you can basically make a list of those, and then these will get pushed to the client by the DHCP server, and the DHCP server will then, the client will then use those and basically try to append those to the short name and send those to the DNS server and attempt to get them resolved. So again, if you only if you know that you need this option, should you even bother dealing with it. Most people will probably leave this blank. The next thing is the default lease time. So the way that DHCP usually works is the client will probably request how long it wants a lease for. It will say, I want a lease, I want to request this IP address for an hour, 3,600 seconds, for example. And that's usually fine, as long as it's within the maximum lease time. Your DHCP server will generally be happy to do a custom time. However, if the client does not specify how long they want the lease for, they just say, I want to lease this IP address, then it will use this default lease time, which is basically in seconds. And you can set this to really whatever you want. And the maximum lease time is basically the longest possible time that a client can request to lease for. So if they request a lease for 2 years, that's a little ridiculous. You would limit this to something. There is a default, and generally speaking, most people will probably never even touch these, and they'll just leave them at the default. One potential reason why you may want to change the maximum lease time is if you're in a situation where client turnover is quite high. So for example, let's say that you have this pfSense box in like a fast food restaurant, for example, like McDonald's, and you've got free Wi-Fi that you're offering to customers. Obviously, there are people coming and going very frequently. And if, let's say, every device requested, let's say, an hour lease time or a 2-hour lease time, if a bunch of people all come in at once, they all get their 2-hour leases and then they all leave before the 2 hours is up. Hopefully you don't spend 2 hours in a McDonald's. And, at that point, all the leases have been used up. And even though the people are gone, the clients are no longer connected to the network, the leases are still given to those devices. And they have to time out after, the 2 hours. So it can kind of use up leases that aren't really being used anymore. So in that situation, you may want to reduce the lease time to maybe like 20 minutes or something, or 10 minutes or something. And in that case, it forces the client to continually renew it if it's still connected. Now, the proper solution for something like that would be that you just use a larger IP address pool, such that you have thousands of addresses available and it doesn't really matter. But that's a potential, that kind of thing is why you may want to change lease time. But generally speaking, most people will probably never need to touch those values. Failover Pure IP, this has to do with CARP. So this is if you have multiple pfSense boxes in a failover cluster. So for high availability, again, something that's most likely going to be used in a large company enterprise environment. You would basically provide the IP address of the other pfSense box's NIC for this particular subnet, and it basically your DHCP server would then basically send that address to the clients, such that the clients know what other device to what other DHCP server, basically what the address of the backup server is in the event that it needs to renew a lease. Of course, it can't go back to the original server because maybe it's crashed. So again, only if you're using a failover cluster should you even need to bother with that. The next option is for static ARP. Now, static ARP, I talked about ARP in part 4. It's the address resolution protocol, and it allows you to it allows a client to resolve an IP address, a layer 3 address, into a MAC address, a layer 2 address. And the way it does this is it sends a packet onto the network, basically asking who has this IP address, and it sends it to everybody. And the idea is that it will eventually be received by the device that actually does have that address, and that device will, of course, will respond saying, I have this address. And then now you know the MAC address of that device and you can communicate with it. And devices will do a probe by sending out who has this address. And once they find out, they will then basically cache that value in a table in memory for 10 minutes, 20 minutes, whatever it's configured for, and then they'll ask again to make sure it's consistently up to date. But if you are in a situation where you have a large network, obviously a large network, lots of clients, there's going to be a lot of devices asking for ARP, they're going to be sending out ARP probes, lots of them are. And if you have, let's say, a bunch of servers and they're constantly communicating with each other, and their servers, they don't really change that much. What you could do is you could basically manually put an entry in their ARP tables on each server saying, this is how you resolve that IP address to this MAC address. Don't even bother to ask for it. This is it. Trust that it's correct. And that way you can reduce ARP traffic by basically statically providing that information to clients. In the case of pfSense, this option basically makes it such that pfSense will only know the MAC address of IP addresses and stuff that you manually enter into the DHCP server. So you can even turn off the DHCP server entirely, and static ARP will still function. So this is basically, you could almost kind of think of this as more pseudo security, whereas of course the router is not going to be able to communicate with devices that are not explicitly listed, that have been manually put in the pfSense router's ARP table by the network administrator. Again, it doesn't stop some hacker from spoofing the MAC address of a legitimate client and still being able to connect, but the option is there. Most people probably won't want to set this. Again, it kind of goes back to the point of, if you want everything to happen automatically, this is not the option for you. But if you have a legitimate reason to do it, this is how you do it. Time format change, I always check this because by default, the DHCP server will log everything in UTC time, which in my opinion is really annoying because you always have to just do the math. So by checking this box, it will use your local time zone that you set in the system general setup. So I like that. Statistics graphs. You can enable RRD graphing for parameters of the DHCP server, and because I like graphs, I will always enable this. The graph adds, it's something like a couple hundred kilobytes of disk space total. So it's negligible. There's kind of no reason not to enable statistics graphs. And it allows you to graph things like how many leases are active, how many are available, things like that. And you can see this over long periods of time. So you can analyze your network that way, how many clients you have at different times of the day, that kind of thing. So next we have dynamic DNS. And this and the next options are listed as advanced options. And a couple of them I don't really think are that advanced, really. Dynamic DNS, basically, if you have a dynamic DNS provider and you want to register not only the address of your pfSense box, but you want to actually have your clients on your subnets registered with the dynamic DNS service provider as well, then you can enable this and you can provide it with all the DDNS information. And so when a client connects, pfSense will basically send that client information to the DDNS service provider and register that client with the DDNS. But I don't think many people actually use this. It's kind of an odd thing, so I generally don't bother with that. The next thing is MAC address control. This allows you to basically create a whitelist and a blacklist for partial MAC addresses. So the idea is if there's a list of like a range of MAC addresses that meet some pattern that you don't want to allow on your network, or want to exclusively allow on your network, you can do that. One kind of strange example would be, let's say that I don't like Apple devices. Apple, because they're such a large company, they license a set of MAC addresses, and all of the MAC addresses on Apple products begin with the same couple sequences. They have a couple, I believe. So what you could do is, theoretically, you could, in the deny list, you could put in those beginning sequences of MAC addresses, and then as long as the device didn't spoof its MAC address, it would be denied simply because it's registered as an Apple product. I mean, you could probably come up with better reasons as to why you'd want to do this, but the facility is there directly in the DHCP server itself. The next option is NTP, which this is something I don't really consider to be that advanced. I think everyone should probably use this. If you set up an NTP server, you can watch my video where I talked about that. NTP, Network Time Protocol, your pfSense box by default actually is configured as an NTP server. You don't really have to do anything; it will run by default. So if you're running an NTP time server, what you can do is you can put the address of this interface, so in this case of my LAN interface, in this box, and the DHCP server will push that to the clients. And if the client so chooses, it will use that server for timekeeping. There's nothing that says the client will use the address. You're simply providing it the address if it chooses to use it. So I'll put the address of this pfSense box there. You can also add another time server for, let's say, an internet time server as sort of a failover. But in this case, I'm just not going to populate that. So next we have the TFTP server. So this is the Trivial File Transfer Protocol server. And I'm not going to go into what this is, but if you want to have a network where you can PXE boot, so basically do diskless booting, you would, of course, you'd need to configure the DHCP server to have all the information about your TFTP server, because when your clients start up, the network card, the PXE boot ROM, pretty much all that is just a DHCP client, and it will find a DHCP server, get all the data from it, and then use that data to actually load the binary and boot the kernel and start the operating system. So under the TFTP server, you would simply put the IP address or even the host name of the server that you have on your network. The next thing is LDAP. So if you have a directory, the server, I mean, this is more of an enterprise thing again, but if you have like an authentication server on your network and you want to push that address using DHCP to your clients, you can enter that here as well. This is truly the advanced options. Basically, you have to know the actual, basically the configuration name and give it a value. And this will be passed directly to the DHCP server. Probably no one will need to ever touch this unless you have some extremely strange configuration that you need to enter. So I'm not even going to go into what's possible to enter in here. Network booting is the next section. It's collapsed by default, but you can expand that. This goes hand in hand with the TFTP server option. So by enabling, if you enable network booting, what you can do is, this is where you would populate all of the information that you need to send to your clients with their PXE boot ROMs. So you would put probably the TFTP server address would be the same as the next server address, and then you'd provide the default binary files for all the different platforms. There's BIOS, and then there's the two architectures for UEFI systems, and then you could, the DHCP server would send that, and the client would go to the TFTP server, use these parameters, and hopefully, if you've configured everything correctly, boot the kernel and start that up. So I'm not going to go into how to set up a Pixie booting server, but this is how you would configure it, and you don't need a separate dedicated DHCP server to do it. pfSense is happy to do it. And the last section down here are DHCP static mappings, and this is very, very important. So let me just save this page first, because I did make some changes. So static mappings, if I just go to add here, this is where you specify devices. First of all, if you enabled the static ARP, in that situation, the only devices that you would be able to communicate with would be the devices that are listed that basically have a DHCP static mapping. So if you enable static ARP, you must populate all the devices on your network with static mappings. The other point of the static mappings is that if you checked the deny unknown clients box, then only the clients that are listed in the DHCP static mappings are allowed on your network. So keep that in mind. The other reason for DHCP static mappings is if you want to do what is known as DHCP address reservation. So if I have a normal DHCP run network, there is no guarantee that when a client connects, it will receive the same IP address every time, right? It could be the same every time for 6 months, and then all of a sudden it just changes. There is no guarantee that the address will be the same every time, and it may jump around. It's completely random. Some devices will remember the last address that they were given, and they will explicitly request it, again if possible. But even that doesn't always work, because who knows if that address has been swiped, by some other client while you were, powered off, for example. So for networks where you don't really care what the actual IP address of every device is, then you really don't need to worry that much. But if you have a network where you have, let's say, for example, a server, that server needs to have the same IP address all the time, because you're going to have clients that are configured specifically with that IP address. And if it changes all the time, you've got to continually reconfigure those clients. Or worse, the clients are going to, they're going to stay running. They're going to just see the server disappear, and they're not going to know what happened. So, it could be something as simple as you're running a Minecraft server on your, on your laptop, or you could be running a file server, or something, or a web server, or something more serious. In that case, by reserving, basically DHCP address reservation reserves a particular address for a particular device and that device only. So you are guaranteeing that that device will always receive the exact same address every time it connects, and no other device is allowed to use that address, even if the original device is not present on the network, like it's powered off, for example. So static mappings are basically done on a MAC address basis. So you would put in your MAC address of the device that you want to create a static mapping for. The client identifier, you're pretty much always going to want to leave this blank. There's a long explanation as to what this really is, but most likely, if you put something in this box, you will probably break your network. So I would recommend not putting something in there unless you know what this is, you've read the RFC about it, and you need it. The next thing is, of course, the IP address that this particular MAC address is going to be bound to. So you need to pick an address, of course, that's going to be used every time. But the other thing is this address cannot be within any of those DHCP pools that I mentioned earlier. So this is kind of a technical limitation to do with how the DHCP server actually assigns addresses. It theoretically can, the DHCP server software will allow you to do it, but it becomes unreliable, and as such, pfSense's actual web interface will actually not allow you to set an IP address within any pool. It must be outside of a pool. And it's just for reliability purposes. So that may be one reason why you want to change the size of the pool or change where the pool is within the address space you have on the subnet, just so that you can fit in some statically mapped or some reserved addresses. Put in the host name, of course. This is really useful. Of course, the device can provide the DHCP server with its host name, or you can put the host name into pfSense, and that way you know for a fact that the host name will be present and will be valid. What can also be really interesting is some devices will actually basically do the opposite, where their host name will be equal to what you put into the DHCP server. So, for example, if you're installing Ubuntu server, for example, it's something that I do quite a bit. Sometimes it's just temporary VMs and stuff, but whatever. What I'll do is I'll create a static mapping for that server, and I'll put a host name in this box. And then when you go to the installer, it will automatically, you won't even have to enter in the host name. It'll automatically get the host name that you've assigned its MAC address from the DHCP server, which is kind of cool. Probably not very useful under most circumstances, but technically it can go the other way if the client so wishes, but usually it's the other way. I just like to set host names here so that if the device doesn't provide its host name, the mapping still has a host name, and I can still use the DNS to access it and things like that. You can just give a description. This isn't actually used by pfSense. It's just it's just a note for your own records, basically, as to what the device is. Maybe put in this is file server, something like that. So as for the ARP table static entry checkbox, you would check this if you want this particular device to have a static ARP in pfSense explicitly. You can check that here. So just as we set a bunch of options for the basically the DHCP server on that interface as a whole, with static mappings, you can set a bunch of parameters. You can override them for specific devices only. So if you had a particular device and it needed a custom gateway or a custom lease time or something just for that device, you can specify it here. So Win servers, DNS server, gateway, domain, all of these options are exactly the same options from the main page that we were just on, except these ones will only be applied to the MAC address that you specify for this exact mapping and this mapping only. And you can add as many of them as you wish. And of course, if you, like I mentioned, if you deny unknown clients, you need to add all the devices on your network to this list. Now, I personally actually do this. I have at least one network, one subnet on in my house that has my main servers on it, and I don't like just anybody to be able to connect to that because there are sensitive machines on that network. So I have checked both of these boxes, and all of the servers have static mappings, and therefore they have DHCP address reservation by default, so their IP addresses never change. But also, if any other devices try to get plugged into that switch, then they will not get a lease, and they, for the most part, people will not be able to communicate with those servers unless I've explicitly authorized devices that can be on that network. So if someone really needs a device on that network, they'll come to me, they'll give me the MAC address, and I'll be the network administrator, and I'll add a mapping for that. If I trust that person, I trust that device, and I know why it's going to be there. So that's the way I deal with some of my networks. But yes, I usually have both on most of my networks. I usually have a couple static mappings, and then a pool somewhere, filling the rest of the address space. So yeah, you would just basically go through this for each interface. You'd configure them differently accordingly. I mean, you may have different address ranges because, of course, they're going to be different subnets, but different address ranges You may have different devices on different subnets. Some are going to be, let's say, maybe this is LAN, maybe this is wireless, Wi-Fi. Maybe you have upstairs, downstairs. Who knows how it is? One thing that I do that you may want to do as well is one of the things that I commonly find myself doing is, because I have a lot of static mappings, I sort of know the IP addresses for certain devices, and some of the devices have addresses that are valid on multiple subnets. So, for example, I have in my home network, I have a LAN, a wired LAN, and I have a wireless LAN. So I have a laptop, for example, which is both on the LAN and the wireless LAN. So what I do is I've added a static mapping for both. And what I do is, of course, the actual subnet portion of the address is different. Of course, one will be, let's say a .1, and the next other one will be like a .2 or something. But I keep the host portion the same, so that way I know that basically I can look at that address and I can tell what device it is because of the host portion, and I can tell what interface it's on by the subnet portion. And it's just something that I've been doing for a long time, and I find it to be kind of helpful. So that may be something that you might want to do if you happen to be using a lot of static mappings across multiple interfaces. So we can take a look, and I know I enabled the RRD statistics graphs. I'm not entirely sure what they'll show because I just enabled them. But if we go into monitoring, and we look at DHCP on the LAN, and we update the graphs. So you can see in this case we have 3 parameters. We have total number of leases, we have number of static leases, and then we have basically the range of DHCP addresses. So you can see that I have at the moment 1 lease, which makes sense because it's the computer, the virtual machine that I'm showing you the web interface on right now. There's no static leases configured, which we just saw, and the range is 236, which makes sense because that was what was configured. So you can see all these parameters over time. Of course, it would get far more interesting as time progressed. But yeah, one caveat that may still exist in 2.3, it definitely exists in 2.2.6 in the current stable, but I have yet to see it in 2.3, but it doesn't mean that it has been resolved yet. And it's kind of a quirk that I've noticed. If you, of course, DHCPD is the service. Whenever you make changes to the DHCP server, big changes will actually require things like static mappings and stuff will actually require the DHCP server to restart. Now this isn't really a big deal because clients only connect periodically, maybe once an hour, and they'll just keep retrying until the server is up. So if it disappears for a few seconds, it's not a big deal at all. Restarting the DHCP server is not a big deal. But what basically when you make a change that requires a restart, pfSense will bring up a banner. And click apply to restart, and it'll restart the service. But one thing that I see happen if you have a large number of interfaces, so if you have a router that has 4 or 5 interfaces that all have DHCP servers on them configured differently, what I've found is that sometimes pfSense doesn't restart the service correctly. Basically, the DHCP server binds to port 63. That's the port for DHCP, and only one instance of DHCPD can be running at any given moment in time. So if you have one running and it binds to port 63, and you try to start another instance, it'll check port 63. It'll see that it's locked, it's bound to another process, and of course DHCPD can't work without a binding to that port, and of course it'll fail. So what I've seen happen is if you have a large number of interfaces and you do this restart, what it's supposed to do is it's supposed to shut down DHCPD and then start it up again, but it seems that it's kind of overlapping the two. It's while the first instance of DHCPD is still shutting down, it will then start up the next instance of DHCPD before the old one is done shutting down. And what will end up happening is the old one will still be bound to a port on a particular interface, and the new one will fail to bind, and you'll end up in this weird state where the DHCPD service will be running on, let's say, like 4 out of the 5 interfaces, but one of them it won't be running on, and all of your devices will slowly lose connections as their leases expire, and you really won't know what the hell is going on. And it's very strange, and I don't know if this has been patched yet. The solution to it, or should I say the workaround to it, is quite easy. It's simply, if it happens, simply stop the service, wait a couple seconds, like 5 or 10 seconds, and then just start the service manually. And of course, that's way enough of a delay that there's no issues. But you can go into the system logs for DHCP, and you can actually, basically, you can see if there's an issue, because DHCP has very good error logging. It will print quite a few lines of error text describing what the problem is, so you'll know if you have a problem. But I generally speaking, when I make changes to the DHCP server, after a restart, I'll usually check this log at the bottom, which is the most current, just to see if there are any big serious errors. Something like, could not bind to interface. If you see that, then you may just want to restart the service manually. If you have a large number of interfaces. If you have 1 or 2, it doesn't seem to happen, but only if it has a lot of interfaces to unbind from does it actually have this issue. And this log is quite useful. Not only, of course, the actual monitoring graph is really good for showing you the number of clients connected, things like that. However, this will show you more of what is connected. So you can see right here, this virtual machine that I'm currently on, which is a host name of PowerPoint, and this is its MAC address. It basically requested a lease for this address on EM0, which is the NIC that's corresponding to the LAN. And then you can see the DHCP server acknowledged that and said basically, yes, you can have a lease for this. And you can see when that happens, and you can see all sorts of things. So this is sometimes good for diagnosing things, seeing what's on your network, things like that. One of the things that I find myself looking at the most is under status DHCP leases. And this shows you a list of all of the devices that have leases, both dynamic leases and static mappings. So static mappings will appear here permanently. They will always be shown. And basically this online column will show offline if the device is not currently connected to the network, but it still has a static mapping. In this case, this is a dynamic mapping. You can see the IP, the MAC, the host name. There's no description because this device doesn't have one, because it's not a static mapping. You can see the start time, which is when that lease was first given out, and the end time. And online is, of course, whether the device is online or offline. It is possible to read offline for a dynamic lease because, of course, that lease, could be longer than what the device is connected for. So in this case, you can see how long the lease is. The lease is valid for 24 hours. So this is a very, very long lease that this Windows virtual machine has requested. And you can see that it's active. You can add static mappings directly from this screen. So by clicking this, it'll automatically populate the MAC address of that device. So you can have a client connect dynamically, and then you can just click that, fill this in, and then it now has a static mapping, which can be quite useful. And you can also add a wake on LAN mapping directly from here. So you can wake the device up from the web interface of pfSense if the device has the hardware and configuration to support that. And there's just a little summary here that shows number of leases in use. This is a new edition in 2.3, but you can also change it between basically all leases or just active leases. So if you have devices that are disconnected, so they're basically offline, you can filter them out using that. So I think that covers everything that I really wanted to go over in terms of DHCP server. It's pretty much the first thing that you should really configure and get working properly. It's not hard. It really doesn't require very much configuration at all. Most of the work is in setting up static mappings for servers and things if you have them. And if you don't have them, then it's very easy. So until the next video, which is part 7, where I'm going to go over the DNS resolver. Until then, hopefully this was interesting and informative. Thanks for watching.